Thank you very much for being a part of this Primus Wind Power webinar regarding the off-grid system and the hybrid solution. My contact information is right here on the screen, as well as all of our tech support number for Bull Colton in the tech support department, and he's happy to help you as well as I with any questions you might have. So just really quickly about Primus Wind Power, we're a division of Primus Metals, which is a precision metal manufacturing company out of Denver, Colorado. So all of our turbines are manufactured here in the USA, in Denver, in our large factory there, which is combined with the Primus Metals factory. We have engineers there and so on. So we're always improving and making our product more robust. The company mission is very similar to what we've had for many years, is that we want to be the largest developer of small-scale wind turbines. We call them micro turbines, with providing a high degree of robust or reliability. We want the turbine to be robust, and we also know that it has to have value. It has to be inexpensive, or it's challenging to compete with the very low prices of solar these days. So that's our mission. Few updates from the industry. Basically, Primus acquired the air product line from Southwest Wind Power in January of last year, and we've been producing it and manufacturing it ever since for a little over a year now. And so some of the things we've done since the acquisition was we've added the Air X Marine, which was discontinued in 2012, I believe, by Southwest Wind Power. We've added it back into the portfolio for marine industrial applications. It's a great turbine for that application. We've also are in development and almost completed on a monopole tower design. So this is a tower without guy wires. It's affordable and UPS shippable along with the turbine and the foundation. And so it'll come with a foundation that has stamp drawings and so on, dry stamp drawings, so that the customer could be able to put this turbine up on a 10-meter tower, so it'll be about 10 meters in height, and it doesn't have the guy wire. So we're excited about that. That's something that's been out there for a long time that we've been wanting to bring to fruition. We're NREL testing. We're testing at the National Renewable Energy Lab in Colorado for this concept, this hybrid concept. Seeing how solar and wind interact. So we'll be talking more about that in the future, and we're also seeing the expansion of this oil and gas market for SCADA platforms, which is a communication platform. So they've used solar in the oil and gas markets for a long time, but now we see them combining solar and wind together because for them it makes a lot of sense because these systems have to be up 24/7. 365, and they have to have on-time performance, and that's what wind and solar combined do. They allow that. Whisper line, the Whisper 100, 200, 500 wind turbine, which was a off-grid wind turbine as well, was sold to a company in India called Luminous Renewable Energy. They are in the United States under the distributor name of John McDonald Solar and Wind, also out of Colorado. So if you need information or your customers have questions about the Whisper, I can give you their contact information. The SkyStream line was sold to a company in Oregon called Exeris. That's the SkyStream 3.7 grid tie turbine. So if you ever have customers interested in that product and need information, I'm happy to help. As far as we know, Southwest Wind Power discontinued all operations as of March of last year. Let's talk a little bit about the turbine itself and the parts and pieces. Starting on the left with the front of the turbine, the nose cone is not just there for aerodynamic purposes to help flow that wind, that laminar flow of wind over the blade set and the hub, but it also helps to prevent water infiltration through the bearings and the hub itself. So it's important to have a hub affixed have the nose cone affixed to the hub of the turbine. To mitigate some of those issues. It is a 3-bladed turbine, 46-inch rotor diameter. All of our turbines, all models of our turbine have the same rotor diameter, 46-inch. except the blade set is a little different in terms of the surface area between the Air X and the Air 30 and the Air Breeze and the Air 40. And I'll explain that a little bit more. As you move through the turbine, here's the face, the stator isolator pad, and here's the stator itself with the windings and so on. And then right here, the brains of the turbine essentially is the circuit card and the internal rectifier with the potentiometer attached to it, which is right here. We'll talk about that in a second. But the circuit card is the control algorithm of the turbine. It's the brains of the turbine. It tells it when to start, when to stop, when to when to start exporting energy to the battery bank, what RPMs to hold the turbine at, when to turn the turbine off when the battery bank is full, and all those things in there. As well as in there is a rectifier, because through the stator right here, the turbine actually produces what we call in the wind industry wild AC, which is essentially unregulated AC energy, and it goes through here, the circuit card, and it goes through the rectifier, and the rectifier rectifies that wild AC to 1224 or 48 volt DC, which then flows down tower to the battery bank. This part of the turbine here, or any wind turbine, is called the nacelle. That's the body of the turbine. And then you have here the inner outer bearings, the yaw assembly, which includes the brushes and the slip rings. And this is the part that connects to the tower. And the tower connection is a 1.5 Schedule 40 or Schedule 80 pipe, steel pipe, which has got a 1.9 OD. And that's the typical tower of the turbine. Again, 3 wires down the battery bank, including the ground. Very simple. All the turbine operations are done up tower. So this is called an up tower turbine. Specifically, it's an upwind up tower turbine because the blade set faces upwind, so the direction of the wind is this way on the blade set, and the turbine is up tower controls. There are turbines out there that have all their controllers down tower, but our turbine has up tower controls. Here's what you get when you get a turbine in from the factory. When you purchase one, 3 blades. They're balanced blades, so if you have an issue with the blade or your customer has an issue with the blade, they do need to buy an entire new blade set with new hardware because they are balanced. If you put another blade on this blade set, one blade could be out of balance and really cause problems, obviously, for the turbine. So they are balanced together. This is a land unit. It is aluminum in color. You know, aluminum. It's not painted. It's just standard aluminum. Whereas the marine versions are all painted with a special paint, corrosion-resistant marine paint. The nose cone are all gray for the land versions, whereas they're white for the marine versions. This is the hub. There's 2 hubs. The hub for the Air 40 and the Air Breeze looks like this. It's got 1 hole in it, and the root of the blade goes in the hub only one way. We call it a smart hub because it's very easy to put the blade on the hub and not mess it up in terms of put it in the wrong direction. And it's got only 1 hole, whereas the Air 30 and the Air X hub, the way to tell the difference is by that hub, and that has 2 holes, and it's a little flatter. So that's really a common misconception or a common question with when we're talking to customers about the differences in the air units. That's a way to tell the differences between the units. Here is the blade and hub assembly process. It's very simple. It takes less than 10 minutes. It's attaching the blade root to the hub, and then screwing that down with the Allen key, attaching it to the turbine body itself, and then the jam nut goes over that, and then the nose cone pops over the hub. Very, very simple process. With every marine turbine that we sell, so that's the Air Breeze and the Air X, that you get a stop switch. And the reason why you have a stop switch with every marine turbine is for 2 main reasons, but there's also a number of other reasons. But for storm conditions, when you're on a sailboat and you see a squall or a storm coming in, and you want to turn that turbine off for a whole number of reasons. You can do so very simply by hitting the stop switch here, and it directly shorts the windings, which is what you really want to do to stop that turbine. And another reason is because any rotating mechanical device, such as a wind turbine mounted to the hull of a boat or a building for that matter, is going to produce some vibration. And that vibration is going to be translated down tower through the tower into the building. And so some folks who are sleeping on the boat, and maybe it's a really high wind speed, and that turbine is spinning like crazy, it could translate some vibration into the hull, and they might have an issue with it through the night, so they would hit the stop switch and then turn the turbine back off in the morning. So those are two reasons why it's a good thing to have on a marine application, but I also recommend a stop switch. So when you're talking to your customers, I would recommend a stop switch for a land application as well. And for the reason why is because we're talking about often off-grid cabins, where if it's a hunting cabin, they could be away from that cabin for several months at a time. It's a good idea to directly short the windings through the stop switch. If that turbine is not going to be charging the batteries, or especially if you have solar with it and it's going to be in regulation mode, meaning it shows the battery is full and the turbine is in regulation, you want to hit the stop switch if you're going to be away from that cabin for a long period of time. If there's a storm coming in when you know there's going to be 70, 80, 90 mile an hour winds, that turbine's going to be in overspeed protection anyway. It's better to throw that stop switch and directly short the windings. You don't have to, because it'll go into overspeed protection and stop itself, but it's just a good thing to do if you're there at the location. So those are just a couple reasons why it's good to have a stop switch in line. This stop switch is a single pole 3-position DC rated stop switch. We call it a break before make stop switch because it actually severs the connection from the turbine to the battery bank as you're going from run to stop. And that's why you need this specific stop switch for our turbine. Just something to keep in mind. Another two things we recommend when you're talking to your customers about installing a wind turbine is adding a amp meter, and this is an analog amp meter, so there's no parasitic draw, there's no milliamps coming out of that battery bank because of the draw of the amp meter. It's very simple to wire and very inexpensive, but it's a good little troubleshooting tool, as well as something for your customers. If it's really blowing, they can see how many amps they're pushing into their battery bank, as well as really highly recommend anytime you're connecting a turbine to a battery bank, you go through a fuse or a breaker. This is the breaker we sell, very inexpensive. It's a $25 part. It's got a little pop out here that you can reset, but very, very simple breaker, but just a good thing to have in line between your turbine and your battery bank. The potentiometer is something you guys need to be aware of. It's on the side of the turbine. I'm going to show you where it's at. So if we're looking at the turbine here, this right here on the side there's a screw that's called the potentiometer screw. I'm going to talk about that just in a second. But while I'm here, I also want to talk about this right down here. There's a little LED light on the bottom underneath the nacelle. So as you're looking straight up, you'll see it on the bottom of the turbine. It's fairly bright, so you can see it during the day as well as at night. But this is something good to know when you're talking to your customers, especially if there's any troubleshooting questions. Obviously, we can take those questions, but it's good for you to know as well. So if this if this LED light is lit, if it's solid, you'll see it's solid. If it's solid, that means the turbine is spinning, it's producing energy, and exporting that energy to the battery bank. So it's working and pushing electrons into your battery bank. If this LED light right here on the bottom of the turbine is blinking slowly, that means it's in regulation. Regulation means it's stopped sending energy to the battery bank. It's shorted the windings through the circuit card. The blades will still be spinning, but very, very slowly, because it's a short to the electronic short to the windings. So it's not like a mechanical brake. It's a electromagnetic brake. So it still might, in high winds, it still might spin those blades slowly, but it's not exporting energy to the battery bank. So that's blinking. If it's blinking very rapidly, like 5 or 6 times a second, that means it's in overspeed protection, which happens at about somewhere between 50 and 60 miles per hour, depending on the gusts and all kinds of things. If it's blinking very rapidly, it's shorted the windings again through the circuit card, and it's told the turbine to stop sending energy and go into overspeed protection, short the windings, slow down that blade set. So just something to keep in mind when you're talking to your customers. So the potentiometer is what you use to, what the potentiometer does. It adjusts the regulation voltage set point. And so here's what the factory settings are for the different 12, 24, or 48 volt systems. But you can set it for anywhere in these ranges. Normally, I'd say 85% of our customers don't touch the potentiometer. But our marine customers often do, as well as customers who have a specific, maybe a sealed battery bank that's a specific, usually a pretty expensive battery bank, typically not with a flooded lead acid battery bank, but even these lithium-ion battery banks and so on, you can adjust that voltage regulation set point to the voltage that is best for the battery bank. And so to do that, you take that screw and you turn it 1/8 of a turn clockwise to turn it up voltage, 1/8 of a turn counterclockwise to turn it down, and here's how much it changes based on the 1/8 of a turn. And so you can adjust that voltage regulation set point. We don't recommend you do that unless you're comfortable and you know what you're doing, because you can fry your battery banks. You can overcharge your battery banks, damage your battery bank if you don't do it correctly based on what your battery, the specifications of your battery. Something that customers we do hear often is that, hey, I'm going to turn this voltage regulation set point, I'm going to turn that potentiometer all the way up, and I'm going to crank out the amps out of my turbine. Well, that's not what it does. It's not going to increase the power output of the turbine. It will not do that. What it's going to do, it just adjusts the point. It adjusts the point at which the turbine stops charging the batteries. Okay, so there's a big difference there. And so customers can really make a mistake by setting that voltage too high. They can potentially burn up their battery bank. They can overcharge the battery bank and damage them. So just something to keep in mind. It is there for the customers who do need to change it for those reasons that we just talked about. Specs of the turbine here, it only weighs 13 pounds. It has about a 1 meter rotor diameter, 46 inches. It's a very lightweight turbine. It has about a 1 meter swept area. You can see the different energy production here for the different turbines. The blades are an injection molded composite of fiberglass and plastic and all kinds of other materials. It is a permanent magnet brushless alternator. Again, alternator, wild AC, right? We talked about that. And the mounting is a 1.5 generally a Schedule 40 pipe, 1.90D. All of our turbines have a 5-year warranty. And our customer support and technical support is right here in Flagstaff, Arizona, and very, very helpful. Talk a little bit about tower height when it comes to wind turbines, because this is a controversial issue with micro wind turbines. Really, we don't see towers above about 45 feet. In fact, the best-selling tower that we have is a 10-meter tower. It's actually the 27-foot guide tower. Because it's inexpensive, it gets you about 30 feet up in the air, and it's relatively short wire run, and so on. So, but if you want to, you can put that turbine up higher. The higher you go, the better laminar flow of wind you get, of course. But does it make sense for the customer? Is the question you got to ask. More, a bigger foundation potentially, or more guy wires, more pipe. Increasing the wire size potentially from a number 8 to a number 6, or a number 6 to a number 4. So all these things increase the cost of the installation. To get a little extra energy, a few extra amps or kilowatt hours out of that turbine per month, does it make sense? And in most cases, our dealers and distributors and customers say no. The predominant size tower is about 10 meters. That's about where they're putting these turbines at. We don't sell a lot of 45 tower kits, to be honest with you. Most of our tower kits we sell are 27 or customers will buy a roof mount kit. Again, when you put that roof mount kit on the side of your non-inhabited energy shed or your shed or your barn, it is going to reduce the efficiency of the turbine because of the turbulence of the vertical face of the building and the roof line, but it's a very easy place to install a wind turbine. And and sometimes that's what really matters for the customer. So just something to keep in mind. Siting a wind turbine is important. Again, we do sell a roof mount kit that goes up through basically the side of the building, up through the soffit, and usually about 6 or 7 feet above the roof approximately. It's a great way to install. It's very simple, very easy, but again, you're going to lose some efficiency because of the fact that there is more turbulence up there. But if it's high winter wind conditions and you have a lot of wind as it is, it may not matter. So something to keep in mind. But when you are siting a turbine, these are things to keep in mind. Flagging, this is what this is called, flagging. You can see where the trees are bent down in the prevailing wind direction, or you see brush up against the fence line. We see that a lot here in Arizona, especially in out towards Doney Park and Timberline area and on the Navajo Res. But when you're siting, the most important thing is just to put that turbine in the prevailing wind direction of the building and so on. And if you put it in the prevailing wind direction, you're going to get your best chance to get the most energy production out of that turbine that's possible. If you have a customer that says that they're on the water, like a lake or a sea or an ocean or whatever, that's great because over water you have very minimal surface roughness, we call it. And so you're going to have these good laminar flow of wind. You can see right here, this laminar flow of wind, these lines are parallel, and that means good non-turbulent wind, so great energy production out of that. If you're up on a hilltop, like this particular application, because as the wind flows up the hilltop, you have minimal surface roughness again, you're going to see that wind start to compress, and as it compresses, it increases velocity, and therefore you're going to tend to have a higher wind speed on a hilltop. Now, on like a building with a vertical face or a plateau or a mesa or a cliff, that wind's going to hit that vertical face and get pushed up, and it's going to break up that laminar flow. You can see this turbulent condition right here. So instead of putting this turbine right here on the edge of the cliff, where some folks would say, oh, that makes sense, let's put the turbine right on the edge of the cliff right here. It's actually better and more efficient for that turbine to be placed away from the cliff so that that laminar flow can come back down and hit that blade set with a good laminar flow, horizontal flow of wind. So just things to keep in mind when you're talking to your customers about potentially siting that turbine. So now we're going to talk about the hybrid concept that really a lot of folks are moving towards these days. The hybrid concept is really combining wind and solar together, and typically what I recommend is if it's a really good wind resource, you might want to have 20 or 30% of the power coming from wind and 70 to 80% of it coming from solar. If it's an average to moderate wind resource, you might want to only have 10% wind and 90% solar, but you want to have some kind of a wind component in there, an additional charging component. And here's the reason why. Because we at Primus, we love solar. I have solar in my house. Bo has solar in his house. Solar is awesome, but it does have a few drawbacks. Here are the 3 drawbacks we see. Solar has low output during the winter months, December 21st, the shortest day of the year. That's why you size your systems for typically December 21st. You have a lot less sun than you have on June 21st. So something to consider. Solar has diminished output during bad weather conditions. So when you have a weather system rolling in, you have those clouds, you have diminished output, but you typically have wind. And solar has no output at night. So on those long winter nights, you have no electrons flowing into that battery bank. It's good to have a secondary source. So on the wind side, we see that the reason why it's important to have a hybrid system and why your customers would benefit from this is these 4 main tenets right here that I'm going to outline, these 4 main tenets. I'm actually going to show you some slides to try to prove these 4 tenets to you. The average wind speed is higher during the winter months. We know that intuitively, but that's actually through data, that's the case. We do have higher wind speeds in the winter months, not a whole lot of wind in the summer. Air density is higher during the winter months because it's colder generally, And if you have higher air density, you have more power in the wind, therefore more potential for energy. Wind on average is stronger during these bad weather conditions. So when you have bad weather moving in, you're going to have wind moving in with that, which is going to help your battery bank. And wind does blow more frequently on those long winter nights, especially in places like North Dakota, South Dakota, Minnesota, Montana, Wyoming, etc. You're going to have those winter nights where you don't have no sun, but the wind is blowing, the wind is howling, and you could be producing energy from that. This is kind of a slide that resonates with a lot of our dealers and distributors and customers, is this complementary nature of wind. It's like Mother Nature telling us that it's probably a good idea, depending on the wind resource, to combine the two. So here we are in the winter months. You have lots of wind, not as much solar, especially during storm periods. But in the summer months, lots of sun, but not a lot of wind. So combining them together is a good idea. The complementary nature of wind and solar. Here's the winter resource map for the United States, and at Primus Wind Power, because of this concept of the hybrid solution, we always combine wind and solar together. Excuse me, whenever we're recommending wind, we always recommend it with solar. We concentrate on winter winds. We don't talk about average wind speeds, because the average wind speed doesn't matter. It's really what matters is the winter wind speed. So here for this chart, you can see the darker blue, the higher the wind speed. Anywhere it's blue, you're going to have high average wind speeds for winter. But you can see all throughout here, the Midwest, up here in the northern latitudes, around the Great Lakes, up here in the Northeast, North Dakota, South Dakota, Montana, Wyoming, etc. All these places have really good wind. Mountaintops here in the Rockies and Arizona right here, right? You have high wind speeds along the coastline, are good wind conditions because that long fetch of zero surface roughness over the water. You can see Florida has terrible wind unless you're on the coastline where you have some decent wind. So just, again, winter wind speeds, a lot, especially here in the Midwest, a lot of the places throughout the United States in the winter, there's a lot of places that have really decent wind. West Texas, here along the coastline as well. A lot of Texas, except for this part right here, has good wind speeds. That's why we have a lot of installations in Texas. We have a lot of installations in Montana, Wyoming, North Dakota, South Dakota, and so on. So something to keep in mind. This is a tool that will be you'll have access to here in April. It's a tool that where you can look at any of the 239 NREL locations across the United States, and this will be a drop-down menu that gives you the location in alphabetical order, and you'll just ask your customer, okay, where are you located? And then you'll ask them what NREL station are you closest to, and then you'll be able to pull up the monthly wind speed, and again you'll look at winter wind speed only. So here is January through December. In this particular example, here's January through December, and you'll focus on November, December, January, and February. That's when they really need the extra energy, right? And so you'll focus on those months, and you'll see, look, well, in this particular location in South Bend, Indiana, in January and February, you had 11 mile an hour or greater average wind speeds for both November, December, January, and February. So in this particular location, probably because you're above about a 10 mile per hour wind speed, 10.5 mile per hour wind speed, this is probably a good candidate to have a wind turbine in this particular location. Also, this is the power curve, how much kilowatt hours are going to be generated for the Air 40 over the month period, January through December. So you have a curve that's telling you, look, not a whole lot of energy production in the summer, but you're doing pretty darn good in the winter months. So this will be a tool available to you. But right now, for now, we have this tool, and I sent this URL. Sorry, it's hard to see, but I sent that URL to Ben, and he should have sent or will be sending that to you in your email. But I want to show you what this does, and this is a tool, again, for 239 NREL locations throughout the U.S. This is 10-meter data, so this is about where the turbine is going to be in hub height, and it's pretty cool. Let me show it to you. So This is, again, NREL data, 10-meter data for 239 locations throughout the United States, and it's in alphabetical order. Each state has anywhere from 4 to 15 or 20 locations. You can see Alabama doesn't have a lot because not a lot of great wind in Alabama. Alaska has a lot of locations. Arizona has 4. But each state, Arkansas only has 2. Not a great state for wind is Arkansas. But all these different states have different locations that you can look at and say to your customer, well, where are you located? Let's take a look at the NREL data for your particular location. I want to look at one state with you. Let's look at North Dakota. Let's look at Minot, North Dakota. Okay, we do sell quite a few into Minot, North Dakota. A lot of off-grid there, as well as oil and gas. And so, nice thing about this is you have not only the wind data, longitude, latitude, and so on, but you also have the solar radiation data, which might be helpful to you guys. So you can look at that for the 12 months of the year. So you have all that data. And again, this is 30 years of data, 1961 to 1990. So 30 years of data. So quite a bit of data here. But what I really want to point out to you here is the wind speed. So down here, if you go to average climatic conditions, and you have, again, January through December, here is the wind speed data in miles per hour for this location. Again, remember our cutoff, it's about 10.5 miles per hour is where you start recommending wind at a particular site. That would be about 4.5 or so meters per second of wind. But here in January and February, look at the wind speeds here, well above that cutoff. November, December, same thing. Again, this is Minot, North Dakota. Now, if you look at June and July and August, you can see the wind starts to die down a little bit, average wind speeds throughout the month. So very simple to do. Takes you, a couple minutes to when you're talking to a customer, ask them where they live. If they're putting in a system, have you ever considered wind? Well, let's look at your wind resource. And then you say what station, what NREL station are you closest to, and you can provide this information for them. You are educated and informed, and that would be very helpful to them to let them know if they're a good candidate for wind or not. And in a lot of cases, you can find out that they may not be, but in a lot of cases, they will be. So, great resource. Keep this one in mind as you're talking to your customers. This is the Canadian Wind Resource Map. It's also a great resource if you have customers up in Canada. Lots of places in Canada have great winter wind speeds, especially along the Great Lakes. This is what the resource map does. You click on a location here. This is, again, the Canadian Wind Resource Energy Map. The URL is right here. This webinar is on our site, on the Primus Wind Power site, so you can access this. You can also Google Canadian Wind Energy Resource Map. But you click on a section of Canada, it comes up on a map, then you click anywhere on that map, and it'll show you the wind resource data that looks like this. And again, you focus on winter. It gives you annual winter, spring, summer, and fall, which is nice. I'll give you the wind rows, which tell you where the predominant power in the wind is coming from. All kinds of great information here. It's in meters per second, so you just to get to miles per hour, it's a calculation is 2.2. So keep that in mind. So very helpful resource here if you have Canadian customers. Western Europe and Northern Europe also some great wind resources. New Zealand, a little bit better than Australia. Most of Australia, unless you're on the southern coastline, you can see not a lot of great wind. Interior of Australia is not great wind at all. So something to keep in mind when you're talking to customers. We talked about air density. This is just very, very simple. Tells you that as the temperature of air decreases, so your air temperature decreases, your air density increases. And so just like with solar, if you have a really cold day, that voltage on your solar is going to go up. Just as in wind, you're going to have more energy production, anywhere from 5 to 20%, depending on how cold it is, of energy production out of our wind turbine, depending on the air temperature. So again, winter wind speeds, winter air density, all makes a big difference when you're talking about energy production in that battery bank. Here's the winter wind during inclement weather charts. So I picked, again, 30 years of data, 3 different sites, and what I wanted to prove here was if when it's less sunny, is it in fact more windy? Does that old saying, when there's weather, there's wind, does that actually hold true? And in actuality, it does. By looking at the data, these are just 3 of the NREL sites. The horizontal axis is the solar energy. So as you go across this, you have more, it's more sunny. And this is the vertical axis is the wind energy. So as you go up, it's more windy. And you can see as it becomes less sunny, it tends to become more windy. That's this curve going up, or this line going up. It's depending on the location, like here in Rapid City, South Dakota, it's much steeper, but just proving that it does, on average, when it's less sunny, it does tend to be more windy. Here's complementary curves for, again, using NREL data for 3 different places on the planet, in the United States anyway, Fargo, Billings, and Minneapolis, and you can see that complementary nature of wind really holds true. Here in the middle, in the summer months, not a lot of wind, quite a bit of solar, especially here in Billings, Montana, but the opposite is true in the winter, lots of wind, but not a lot of solar. Something to keep in mind when you're talking to your customers. You guys have probably all seen this, the solar day. So again, this is the average solar day for June and December for 30 years here in Rapid City, South Dakota. Quite a distinct difference. Look at the amount of time during the day in June that you have solar radiation hours versus in December. Quite a distinct difference. So not a whole lot of time in December to really push electrons into that battery bank. That's why it's important that you have that secondary charging source. If you add on a winter storm in here that pushes that battery bank down even farther, if you've got only solar, it really makes sense to have wind. Same thing with nighttime here in Cheyenne, Wyoming, winter months, 1990. Again, you're going to be above 13 miles per hour pretty much throughout the whole day. Again, this is going to be all over the place because it's wind, but pretty much throughout the entire month, you're going to have wind conditions that you're going to be pushing energy into that battery bank in the winter. You've all seen this before, I'm sure. This is a Trojan brochure of different types of batteries, anywhere from AGMs to gels to flooded lead acid and so on, and the depth of discharge for those different types of batteries. I know that most people size their systems for maximum of 50% depth of discharge for December 21st. So basically what we're saying here, by adding wind, you could push that depth of discharge up to lower levels. You could be in the 20 or 30% or 40% depth of discharge if you have an auxiliary charging component in that system. So what that's going to do for you and your customer primarily is it's going to allow that customer for that battery bank to potentially be maybe a little bit smaller, to add a few less solar panels, and that battery bank potentially is going to last longer because you have those electrons flowing into it during the storm periods in the winter, or during December and January when you have a lot less sun. So it pushes you up on this scale, this cycle life chart, to allow you to have an extra 200 or 300 or 500 cycles out of that battery bank, so that that battery bank will last longer. So, solar is inexpensive. We all know that. It's very simple. A lot of customers will say, well, let's just add an extra couple solar panels, and maybe I'll get myself through the winter months better. I'll have to use my generator a little bit less. And that's true. You can do that. It's relatively inexpensive to do that. But if you have to add a charge controller, especially an PPT charge controller, it can get expensive. And so what we recommend really is the best solution, if you are in a good wind resource, is to add an auxiliary charging component, a wind turbine, into the system. And especially if it's an inexpensive turbine, you can add it directly into a system, either an existing system or a new system. It could be wired directly in the battery bank because of all the up tower controls. Very, very simple. and relatively inexpensive to do that. It still might be slightly more than the cost of adding solar, but again, you have those two charging sources for when you have a storm period or in the winter months when you don't have as much solar. So just a little reminder that this air turbine's been around for a long time, started in 1995 with the 303, the 403, and then the X, and so on. And it's just lots of units out there, over 150,000. Great support from us at Primus. Lots of tweaks and changes to the turbines over the years to make it more robust, more reliable, quieter, etc. So it's not a Johnny-come-lately turbine. It's not a Chinese model that you're concerned about the support, and it's only been around for a little while. So just something that's also a nice, when you're thinking about wind, you want to have a turbine that's been out there for a long time, like a Berge or like an air unit, because we've been around for a long time. So just remember, when you're talking to your customers about which turbine to pick, there are a variety of these turbines. There are actually 4 different flavors in the 3 voltages, 12, 24, and 48. And so most applications are going to be either the Air Breeze or the Air 40. These are the same turbines, except for the Breeze has the painted coat on it, the marine coat on it. The Air X and the Air 30, these are the same turbines, except for this one's got that painting on there, that coated on there. But in a low to moderate wind regime, this is the turbines of choice. For higher wind regimes, you want to go with the Air 30, the Air X, as well as industrial applications. So any oil and gas, offshore application, a marine buoy application, scientific instrument application, any of those type of applications where it's not really going to be around people, telecom application, railroad application, that's where you'd go with the 30 or the X. If you want a quiet turbine where it's going to be around people, the 40 and the Breeze is the way to go. If you have a really high wind speed application, this might be a good way to go. This is a very limited amount of our applications. We don't see this very often, but you can hook up a TriStar 45, which has that auxiliary input, has the wind input, and a dump load, a diversion load to it. And what that does is you open up the potentiometer, and when the TriStar sees high battery voltage, instead of shutting the turbine down, it actually starts to dump the energy into either a resistive dump load like a air heater or a water heater. So really a good way to go. It does make the system more expensive by adding these components, but it's a way to get all the usable energy out of the wind, especially if you're in a high wind speed area. We do see this application, and it can make sense. Comparison chart, here's the MSRPs on the turbines, the land versus the marine. All of them have a 5-year warranty, and the sound, there is a sound difference between the turbines. The reason for the sound difference between the Air 40 and the Air 30 is really twofold. Number one, with the 40 and the Breeze, you have a wider blade set. It's a little stiffer. It spins at a lower RPMs, which helps to control the sound output. The 30 is a thinner blade set. It spins at a higher RPMs, about 1,800 RPMs. It has a feature in it called aeroelastic stall, which allows the blade tip to flutter as it gets up into those higher RPMs, and that produces quite a bit of sound. So keep that in mind when you're talking to your customers. Any turbine worth their salt is going to have a power curve and an energy curve. This is the power curve for the 4 turbines we have, the Air 30 and the Air X and the Air 40 and the Air Breeze. You can see this big spike right here is because this is that 1,800 RPMs at high wind speeds. It can produce over 400 watts, whereas the Air Breeze and the Air 40 is pushing 250 watts. Really, most of the time it's at 200 watts max. So something to keep in mind. But the reality of it is that 40 and the Air Breeze is going to outperform the 30 and the Air X at the lower wind speeds, which is the majority of the time you see wind, and that's below 25 miles per hour. So keep that in mind when you're talking to your customers. Here's the energy curve. So this one was instantaneous power at any given time in watts. So this one is kilowatt hours in a month. And so that's why the 30 is called the 30, because it Air 30 in a 12 mile an hour wind speed will produce 30 kilowatt hours a month approximately, and the Air 40 in a 12-mile-an-hour wind speed will produce 40 kilowatt hours a month. Remember I said the Air 40 is going to outproduce the Air 30 and the Air X at those lower wind speeds because of the more surface area on the blade set, and also the control algorithm is optimized for those lower wind speeds. So that's why you get these dotted lines right here as you get up into higher average wind speeds. So this is an average wind speed here. So if you're in a 13.5, 14 mile an hour wind speed average for a location, that's a very, very high wind speed. In that location, you would never want to put an Air 40 in there. It would be an Air 30 or an Air X. Here's the sound data for the Air 40 and the Air Breeze. Again, remember those are the same turbines, except for the Breeze is marinized. And the blue is the turbine in operation, and the green is the background noise. And a maximum of 65 decibels on this one. You can see the blue and the green kind of all blend in together as you're going up with this decibel chart, and the wind speed increases. Not until you get above about 25 miles per hour do you start to actually hear the turbine, the blade set of the turbine. Anything below that, the turbine will just blend right into the background noise. So it is a very quiet turbine. Let's look at some pictures. This is kind of how it all started with the air units back in 1995 for off-grid cabins, just to power a few lights, maybe a well pump, a water pump for water and lights in the cabin. This is a 45-foot guide tower, 8 guy wires, schedule 40, 1.5-inch pipe. This off-grid cabin application. We still see a lot of this today. Here's another application, again, very remote, right? The Mulligan steps here. Very simple application. No solar at all, really, in this application. Just a wind turbine on a 27-foot tower, powering some lights. This tower they can take down and move with them if they want to. It's very, very simple. That's an Air X from back in the late 1990s. Still see a lot of this today. We still see a lot of these applications. Another application we have is marine. This is a mast and stay. You can see the stay here, the metal stay, and the mast. This is an Air Breeze on this sailboat. Very great application for sailboats because there's not a lot of real estate on the deck of a boat, and so they love to put wind turbines on boats. Again, here are more boats, different applications, different ways they are mounted. This is a trimaran mounted on the back of this boat, as well as they can mount them on the mizzen mast here of the boat. Multiple turbine application with solar on this particular one. So again, here's 2 turbines with the solar panels. Parking lot light applications, we often see this. This is oil and gas. Very short towers, again, because you have very little surface roughness here, but always combined with solar, hybrid solutions. They love these things in North Dakota, West Texas, Pennsylvania, New York, in the Marcellus Shale, and so on. These are energy skids that they use in West Texas. Batteries, controller, 500 watts of solar. This is this is a lattice tower up to a stub pole, 1.5 schedule 40 pipe, about 20 feet up in the air, West Texas. They work great. These tilt down for transportation. Really great system. This is Antarctica. I just wanted to point out that these 2 turbines are at different elevations because this is upwind, and as this turbine in the upwind position captures energy, the downwind turbine, if it's at the same elevation, is going to have a downwind shadowing effect. So you always want to, when you're talking about a multi-turbine installation, you always want to have them at 2 different elevations so that you don't have downwind shadowing effects. Same thing here on this buoy platform. You have solar and wind. This is an Air X Marine. Again, great industrial use for the turbine. 2 different elevations so that you don't have downwind shadowing. Telecom applications are big. Railroad, we work a lot with BNSF. We see a lot of this kind of application. RVs, people will put these things on their RVs. They'll design their own pole kits. This is a mast and stay kit that we sell for the marine applications. They just use this on their RV. And here's Alaska. That wind turbine is spinning like crazy, but the solar panel not doing so great. You can see it's directly wired into the battery bank right there. So hope you learned something in this webinar, and I sure appreciate you guys listening. Again, here's my information. Happy to talk more as you need help.